Well, good morning, everybody, or afternoon. Thank you for joining us. And it is my pleasure to provide kind of really a big capstone overview of everything that you have already seen, starting from the reason behind this project of the North American project to evaluate soil health measurements, and really pull together everything that Diana, Liz, and Dan have already covered. So what I'm speaking about today really are those recommended measurements for scaling soil health and assessment. And when we're talking about scaling, I think that's a really important component here, where we really were looking at identifying these effective, widely acceptable and measurements of soil health. And in particularly, when we think about scaling, an important component of that is that, these measurements need to be available to everybody in commercial labs that, want to measure and track their soil health. But before I really start talking about those, I just want to do a little bit of level setting. Again, when we talk about soil health, Wayne already covered a little bit of that, but I think it's important to recognize, Wayne talked about soil health, and then he showed the different soil mapping units across North America. And I'm going to do it a little bit of a different way, more of a point basis. To first talk about soil health in this left-hand slide, we can see the same soil, different management. And in this particular example, which is a picture I know I show a lot if you've seen my other talks, but in this particular example, we see on the left-hand side, so there's been a rainfall, and on the left-hand side, there's some surface sealing going on. There's erosion and deposition within this field. And as a result, there's also a variable response of the crop to the hydrology of the field. Whereas on the right-hand side, again, same field, same soil, same slopes, same environmental conditions. However, the management has changed. And then we can also see just a different response of how that soil under this no-till management with a lot of residue on top is not showing some of the same problems associated with hydrology. And so this is the concept of soil health, right? That we can take a soil and we can change the management to either improve its functioning or degrade its functioning. And in this particular case, the functioning that is shown in this photo is really that functioning of water movement and biomass production. So on the right-hand side, then I also want to point out, why do we struggle so much when we talk about soil health and understanding soil health, measuring soil health? And it's because of this concept of really these inherent differences between soils. Anyone that's worked in a farmer's field or traveled across the country or has paid any attention to soil will recognize that soils vary a lot in space. Right. So in this particular example, I have a beautiful alpha sol from East Texas. It's very sandy on the surface. A lot of the clay has alluviated down below. Excuse me, it's still a very deep soil, but because it's sandy, it's going to have very different nutrient and water retention capabilities. And then on the right-hand side, we have a soil that's very silty. So it's got, again, different nutrient and water holding capabilities. But this soil is very shallow, and so it's not going to hold as much water. And so its response to management is going to be significantly different than that to this sandy or deeper soil. And I just want to recognize, though, that though these soils are very different genetically or in their inherent properties, they can both be healthy and they can both express changes in metrics associated with indicating whether or not they are healthy. And that's really how we want to boil this down to, is to know, is our soil healthy and can it improve? And when we're thinking about assessing this healthiness of the soil, we can kind of think about it in one of two ways. One is the management that I'm implementing on a particular soil, moving that soil towards a healthier state. So a very relative, is my soil healthy today? Is it getting healthier? And the way I like to think about this is just an indicator of progress towards some sort of target soil health. Now, this can be very qualitative. Obviously, at the Soil Health Institute, we're very focused on quantitative measures that are repeatable and reliable, and usually measured, with a given number rather than categorical. But we can also think about, is our soil performing individual jobs to the best of its ability? Liz alluded to these ecosystem functionings, right? Like, are we losing nitrogen to the air or through leaching or on surface water? Are we losing surface soil material? So some of these functional outcomes we think about we might want to measure include carbon storing carbon and cycling carbon, same storing and cycling nutrients, storing and cycling water. Those are the ones that I always think about, but also resistance to erosion. I noticed in one of the Q&As, there was a question about aggregate stability and its relationship to soil erosion. And so these are a lot of the measurements that these indicators that we measured. Suppressing disease and pests is something that we really didn't focus on in this particular project, but it's also important when we're thinking about the healthy functioning of our soil. And so you've seen this table before, what measurements we evaluated, and you can see though that that's kind of why we put these measurements in different columns of carbon, nitrogen, water, and then the community and kind of some of the other properties, some of the contextual measurements that we made for this project. And again, given all of these measurements we made, our goal is to identify effective, widely accessible measurements of soil health. And so this is how we filtered it. And though this figure, as I look at it, it's so simple and clean, but this is really the result of a lot of conversation with Soil Health Institute scientists, and partnering scientists, conversations with scientists all over the world, policymakers all over the world, and gosh, just anybody interested in soil health, talking to farmers, talking to the laboratories. You know, we really have been doing a lot of outreach and hearing and listening and thinking ourselves, like, how do we use this data? How do we use the knowledge that we already have in soil science? And how do we remain practical? If we want to scale, these measurements that we choose have to be accessible, they have to be reliable, they have to be implementable, and they also have to be affordable. One of the things I always remember one of our stakeholders saying is like, we're very interested in soil health, but we're not going to measure it if it costs $150 a sample. And so those are kind of some of the more impactful things that we've been thinking about. And so this is the way we want to think about it. And this is the way I'm going to talk about it today. So first of all, we have these filters, right? Does the measurement reflect soil health, or is it a reflection of something else just as important, but not specifically an improvement or is something we expect for soil to change due to management? Once those measurements went through that, we thought about, and in this, of course, the information we use for that filter is really the literature, our soil knowledge. The next filter were the measurements responsive to management practices? And, you know, Dan did a really nice job of showing how we thought about not just the practice, but the practice in space and what did those trends look like with rainfall and things like that. And here we really relied on our NATURE results for this filter. And that's a lot of what Dan and Diana and Liz were talking about today. Thirdly, is it applicable at scale? And this is where we really had to put on our, talking to practitioners and listening to practitioners and even ourselves. You know, Soil Health Institute doesn't own a lab. We don't do our own analysis. So we're really engaged at figuring out what commercial labs can do reliably and at scale and affordably, because we also are writing grants and trying to get, national rollout of soil health assessment. So this applicable at scale really came from a lot of talking with labs, looking at prices, looking at availability, and working with people that go out and professionally soil sample and figuring out like what can we do and what's too much to ask of people. And then lastly, we still had a lot more measurements than we wanted to recommend. So we really thought about like, okay, which of these measurements are redundant with other measurements? So we wanted non-redundancy, but then when we're selecting, maybe something about carbon, we really wanted to look like which of these measurements is most direct to the interpretation that we think is important for farmers, for soil managers, and for stakeholders and supply chain information. And there we also used a lot of information about our NATURE results, looked at the literature, and really thought closely about, what people are asking about soil health and soil functioning. Okay, so now what I'm really going to do is just like walk through this. And so the first filter is we looked at, do these measurements primarily reflect soil health? And our thinking around that went to, is this a fertility measurement? Is this a measurement of an inherent soil property, like texture? And when I talk, I'm going to back up a minute. When I talk about fertility management is something that farmers are already measuring, right? Hopefully NPK analysis or micronutrients. And we can fix this, right, by adding organic or inorganic nutrients. Other thing we looked at is like some of the measurements were really associated with scientific discovery. A lot of what Liz talked about today, was like, hey, we just want to take these measurements, but we don't think that they're applicable to scale today, but maybe they will be tomorrow, or they can be linked to something that's functionally very important. Then we also had some measurements that have to be done in the lab at some sort of fixed pH, and they start to lose some of their information because perhaps we have to fix a pH at 7, but this soil particularly functions around a pH of 6.5 or something like that. And that was a lot of those enzymes. So let me just go on to the table. So same table that you've already seen before. And we think about the measurements that we took out that were very related to fertility, just had to do, with the soil elements and fertility measurements. So those are taken out of the table. And then we looked at, okay, inherent soil properties. So it was in the Q&A session. If you want to look at the question and answer, someone pointed out that wilting point and repacked field capacity. So really, if we look at water held at really, really dry, or if the structure has been destroyed, those are really related to the soil texture. So not necessarily something that we expect to change with management. And same with some of these inherent soil properties like texture, electrical conductivity, pH. pH does change with management, but we really want to think about, is this soil calcareous? Is it neutral? Is it basic? And a lot of times that's an inherent property of the soil. And also inherently, does the soil have, is it calcareous? Does it have inorganic carbon? So we took those out. I already alluded to these enzymes. We took them out. We just really didn't think that they were quite scalable continentally. And then lastly, a lot of the beautiful data that Liz took and everyone's so excited about. Yes, very worth investigating. All of these measurements that I've even taken out thus far, like they still need to be measured about our soil for research and understanding soil processes. But really, they kind of fall in that scientific discovery realm. So we're going to take those out as well. And so now what we're doing is we're going to look at, and really this were these NAPSHM results, right? Which of these that are left were responsive to management practices? And Dan spent a lot of time explaining how we did a lot of this analysis. And all of this is in those papers that Diana pointed out that are published, and Dan and Liz's papers as well. But essentially the principle was, we looked to see if the measurement was responsive to management practices that exemplify soil health principles. So here on the y-axis, we have some of these managements that are associated with soil health principles. And then we have these log response ratios to see, did the measurement that we were interested in actually respond to this management principle? And again, Dan, Liz, and Diana really covered a lot of that in detail. Okay, so this is also just a review, but to be completely transparent, the measurements that we removed because they weren't as consistently responsive included the potentially mineralizable carbon with a 96-hour incubation, potentially mineralizable nitrogen, water extractable nitrogen, the wet sieve aggregate stability procedure, Diana pointed that out, and then saturated hydraulic conductivity. Being a soil physicist, this really hit at my heart and my bones and my structure, but truly saturated hydraulic conductivity is a very difficult measurement to make, and to make enough of them so that they're reliable. So here we go, by saturated hydraulic conductivity, out of there. Okay, so the next thing that we really looked at when we tried to filter these soils out, or these measurements out, is, are they applicable at scale? Okay, so we're looking at price and availability. So here are some examples. Bulk density, we love it. It's really important for if we want to track changes in carbon stock. It's telling us about porosity and it's responsive to management. It's a gorgeous measurement. it takes a lot of labor and skill to get this measurement done and get it done well. And I have lately extensive experience with a lot of talented people trying to take bulk density across the continental US, and it is hard. And we don't have good ways to do that. So, that's why we're like, bulk density, great, hard to get. Same, this plant available water at field capacity of intact soil samples. We have to essentially take a bulk density sample, put it in this plastic container. We ship it off to Cornell's lab. They do an awesome measurement and an awesome job, but it's quite custom and not something that a lot of people can do and not really available in the laboratory. So these are some of the ways we're thinking about stuff. On the other hand, we love this wet aggregate stability by image analysis measurement because it's so easy to do. And we are working on an app that already the Slakes app is available. And we're working with the University of Sydney and app developers to make the Slakes app more reliable and easier to run. So these are just kind of things that are going on in our head and how we're really kind of thinking about what this minimum suite of measurements that are applicable and available. So I already told you intact field capacity, sad to see that go again. As a soil physicist, it hurts. Sprinkle infiltrometer, mean weight diameter. These are great aggregate stability methods that I highly encourage researchers to continue to use. But again, they're expensive and a lot of commercial labs just won't do them. We've talked to them. Bulk density, same, already explained that one. And then lastly, microbial biomass, PLFA, it's expensive compared to the information that we're getting from it. Okay, so lastly, you can see from this that we still have quite a few measurements left. And again, in my head, I'm still thinking through, this can't be a $150 measurement, Cristine. So we really pushed ourselves and thought a lot and argued a lot and asked questions and read the literature and listened and reduced our measurements by even more. Total nitrogen, as Dan pointed out, is highly correlated to carbon. Most of the time when you go by dry combustion, you're going to get carbon and total organic carbon and total nitrogen at the same time. However, if we use spectroscopy, we won't have total nitrogen. So we just wanted to say, okay, no total nitrogen. Again, Dan really explained why we didn't choose POC and ACE, but again, it just went back to that, well, they're so correlated with organic carbon that they're just kind of becoming redundant. Same with water extractable carbon and organic matter. So in the end, we've created this table to kind of simplify our thoughts, but primarily we have these indicators: organic carbon, potentially mineralizable carbon with a 24-hour incubation, aggregate stability, plant available water, really important indicators. This bottom plant available water, I should have written predicted plant available water because we're not actually recommending it be measured directly. Since we're already measuring organic carbon and hopefully you already know the texture of your soil or you can measure the texture of the soil, we can use the pedo transfer function that Diana spoke of earlier today. But anyway, here are the indicators, 4 big indicators. The measurements associated with those indicators that we recommend: dry combustion for calcareous soils, we need to get rid of the inorganic carbon. 24-hour CO2 burst resulting from re-wetting air-dried sieved soil. The measurement for aggregate stability that we really like, that we think is scalable, is that 10-minute change in slaking via image analysis. And then using a pedo transfer function with the organic carbon measurement that we've already made in soil texture to estimate changes in plant available water. And ultimately, this is the kind of the way we're thinking about this. Soils change across the landscape. Every soil can be healthy and express healthy, but we know that a healthy soil in the Midwestern United States does not have the same health as a healthy soil in the southeastern part of the United States, and so forth and so on. So we just really want to point out that we're working on this to scale soil health assessment continentally. We're really thinking about our soil health targets concept and how we can look at soils, group soils into soils that we think should have similar soil health responses and compare those together to some targets and thinking about how soils change with management, given their inherent properties and the climate that they're in. So with that, it was fast, hopefully mostly a summary and clear can be, Lakeisha. I do want to point out all the hard work everybody on this graph, this final slide did. Present and former SHI staff, you know who you are and your names are here. Thank you so much for your hard work and your deliberations and your conversations. Thank you to our nation partnering scientists. You know this would not have been done without you. And lastly, thanks to the financial support of the Samuel Roberts Noble Foundation, General Mills, and the Foundation for Food and Ag Research. It's all you, Lakeisha.
Thank you. Well, you don't get away that quickly. We have maybe I know time for one question. And this one has been upvoted a couple of times. So there's a question around the role of fertility measurements in soil health. So if you could speak to maybe why they not necessarily aren't considered a part of soil health, but aren't necessarily counted in the way in which in the research presented.
Yeah, so this is a real tough one. And I want to step back for a minute. And it's very interesting. I just recently returned from the World Congress of Soil Science. So obviously big global meeting of soil scientists, and we were talking about soil health. And when we talk about the soil health in North America, we don't direct, like the NRCS doesn't specifically have nutrient management as a list, right? Because we really take it for granted that we have access to nutrients, and we're going to modify nutrient management, whether we're thinking about soil health or not. And frankly, we could have a very unhealthy soil that's very high in nitrogen. And we can have a very healthy soil that's, where the nitrogen's kind of tight, and it's a tight nitrogen cycle. So we just wanted to decouple that a little bit. However, I do want to point out that when we think globally about soil health, if we don't have living roots, and if we're not producing photosynthesis or biomass, then of course we can't do a lot of these things. So fertility is such an important component of good holistic soil management, but we really, it is important. And in places where nutrients are sparse, I can imagine that fertility has got to be the first thing that you focus on. But it is coupled, right? Like also good organic matter management comes with good fertility. And ultimately, we like to think that we can build that organic matter and reduce our inorganic fertility contributions. So I know I totally hedged that, Lakeisha. But, we're really looking at detecting changes in soil processes due to management. We really wanted to focus on soil health management as prescribed by NRCS.
Absolutely. Thank you so much for that, Cristine. So now this does conclude the end of this session. And I have the pleasure of announcing the lunch break. And I believe also there will be a QR code that will be put up in a moment. So I want to thank all the speakers. I want to thank everyone for your participation and attention. We had over 500 participants in this particular session and a number of questions that we haven't even had the chance to get through all of them, but hopefully we'll get through a majority of them. So I just want to also mention that the CCAs, the CPAGs, CPSSs, or CPSCs can log into your application and snap the QR code that will at some point be put up to receive credits for that session. So I'll pause here and hopefully that'll be put up. There it is. And so that is the QR code that you can snap for your credit for the code. And then participants should resume and the speeches will resume at 1 p.m. Eastern. So enjoy your lunch. Thank you so much for your time and attention. Thank all the speakers and the sponsors. And we're quite excited for the next round of conversation. So thank you for allowing me to moderate this session. It's been a wonderful, informative, dynamic conversation, and I'm sure that it will continue for the rest of the day. Thank y'all.
Thanks for joining, Lakeisha. It's great to see you.
I know, great to see you too. Thanks for having me.